Okay, 10.4, the inverse of a square matrix. What is the inverse of a square matrix? Well, first you need to know what is a square matrix. Square, just like in geometry, a square has the same side, all the sides are the same size. So in this case, a square matrix, the number of rows is the same as the number of columns. For example, here we have a square matrix. It's a 2 by 2 square matrix. We call it 2 by 2 because it has 2 rows, 2 columns. We also call it a square matrix in the order 2. In the order of order 2. Actually, square matrix of order 2. And here we have a square matrix of order 3. That means 3 rows, 3 columns, or a 3 by 3 matrix. Alright, so talking about 2 by 2 matrices, we have a special kind of matrix called an I2. We use a 2 because, we're talking about a 2 by 2. But we can also, later on we're going to work on I3, 3 by 3, but it's the same concept. So, how do you create an I2 matrix? Very easy. Just do a diagonal, and just put a 1 and a 1 here, and a diagonal, and a 0 and 0. So it's 1, 0, 0, 1. And has a special kind of property that for every 2 by 2 matrix, for example, A, B, C, D, if we multiply this matrix by the special matrix, we'll get the same matrix. And if we reverse the order of the factors, we'll still have, I2 times the matrix, we'll still have the same matrix. So, a matrix times I2, we get a matrix. And I2 times the same matrix, we still get I2. So, to better understand this, we can, compare this onto real numbers. In real numbers, if we have a number and we multiply by its inverse, we're going to get a 1. So, any number, 3 times 1 over 3, we're going to get a 1. Alright? So, this special matrix plays, the same role as in the real numbers. This is like a 1 for real numbers. Because, it's like a 1 for real numbers. So we're saying that if we reverse in matrix, you have to have 2 tests, okay? Because a matrix is not the same as a real number. In a real number, if you have 2 times 3 equals 6, and 3 times 2 is also 6. So it doesn't matter if we reverse the factors. Well, in matrices, if you reverse the factors, then you might have a different kind of animal. Unless, of course, the matrices are inverses of each other. If they're inverses of each other, then that takes us to the next topic. Inverse of a 2 by 2 matrix. There's 2 tests. If you multiply A times B and gives us a special matrix, and then you still have to check if you reverse the factors B times A, we still have I2, this one right here, then they're inverses. So we need 2 tests. AB should give us this one, and BA should give us this one. So let's give you an example. Let's work through an example. We need to find the inverse of this guy. And like I said, we're looking for another matrix to see if we can find an inverse. So we're going to call this one A, B, C, D. So we don't know the numbers yet. That's why we use letters. And so we're going to do 2 tests. A times B should give us I2. And then B times A should also give us I2. So what we're going to do, we're going to multiply A times B equals, and then B times A. And then we're going to form systems of equations using I2 on the right hand side. So let's, this is better explained by rolling up our sleeves and getting to work. So we're saying that if we multiply A times B, So this is A, 1, 2, 3, 4, times B. A, B, C, D should give us the special matrix 1, 0, 0, 1. And likewise, if we reverse the factors, we have A, B, C, D times 1, 2, 3, 4, it should give us a special kind of matrix of 1, 0, 0. So these two tests. So if we find variables for, if we find values for the variables A, B, C, and D, and then we satisfied these two conditions, then we can say that we found the inverse of A. So instead of B, if we find variable, then we could call B should be equal to A inverse. Alright, so let's get to work. I'm going to raise the second, because I'm going to work in the first test. So we're going to find variables. Values for variables. At this point, you should be able to multiply. You should be able to know how to multiply two matrices. So just a refresher, I'm going to do it for you. So we'll grab the first row and the first column, and then we're going to create like another. It's like another matrix. So first row, first column, and then we put it right here. So take the first number and the first number, so 1A, so A plus, and the first number here and the first from here, plus 2C, and then for this spot, we combine this one and combine this one over here. So 1 times B is B, 2 times C, times D plus 2D. And then we're going to work on the second row and first column, and just put it in the first column. So 3 times A, 3A, and then 4 times C plus 4C. And then we work in the second column, 3B, 4D. It looks like we have ourselves two systems of equations. So all we're missing is the right hand side for everything. So the right hand side for everything. To complete the two systems of equations, we're going to use this special array or matrix, and just put the corresponding position. First row, first column, put it here. First row, first column. And then 0 goes here, and then this 0 goes here, and then this 1 goes here. So now we completed our two systems of equations, and you should be able to know how to solve these two. So we have one system here, because we have two variables, two equations, and then we have another system here, two rows, two variables, and if you do this, you will find that that you have another matrix with these values: -2, 1, 3/2, and 1/2. So you found values for A, B, C, and D. By solving these two systems. So you have these values, but you still have to do another test. The first test that we did was, A times A times B equals I. Now we have to do B times A equals I. So B times A equals I. I said B is the array of the matrix we're looking for. So we're looking for A, B, C, D. And then we're going to multiply by A. 1, 2, 3, 4. And we should still get the special array or matrix 1, 0, 0, 1. And then again, we can do the same thing, you know, multiply these two arrays, and for the sake of practice, let me do it again for you. So we're going to do first row, grab the first row and first column. So we have A plus 3B, and then we go first row, second column. So we got 2A and 4B, and then we got second row, first column. So we get a C, and then plus 3D, and then we got first row, second column, 2C plus 4D. Same thing, we use the corresponding values. So this one, first row, first column, first row, first column, and then first row, second column. Same thing. So if you create again two systems of equation, in this case this is the first system and this is the second system. So you should be able to solve for this, and you'll find that you get the same values, the same and if you get the same values for A, B, C, and D, then indeed this is an inverse of A. So the last test that we do, so we got minus 2, 1, 3 over 2, 1/2. The last test that we do is we should be able to multiply B times I 2 should be able to get B, because this is multiplicative identity. And A times I2, we should get B. Not B. We should get A. Alright, so let's do the first step. So we found B, so let me retrieve those numbers again. So minus 2, 1, 3 over 2, minus 1/2. So let's do this one, minus 2, 1, 3 over 2, minus 1/2. That's B times I2, 1, 0, 0. We should be able to, we should get minus 2, 1, 3, 2, minus 1. So that's one test that we can do. So we grab the first column, first row. So 2 times minus 2 equals 4. And then, oh no, we're not doing it. No, we're doing this. This. Okay. So we have minus 2. And then 1 times 0 plus 0. And then we grab the second one. And then get 0 plus 1. And then second row, first column, 3 over 2, and then minus 2 times 0. And then 0 plus minus 1. So you'll find that we still get minus 2, 3 over 2, and then 1 and u2. And thank you for watching.